All right, my friends, welcome back to Build Science
201.
Talking separation, inside versus outside. You ready, Steve?
Yeah, I mean, as easy as a concept as it sounds, man, is this a difficult one in reality.
This is honestly one of my favorite episodes. You guys ready? Build Science. Let's get going.
Build Science 201 is sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco.
Hi there, I'm Matt Reisinger, and today I want to share how zip system building enclosures are truly transforming the future and frankly the present day of construction. The zip system portfolio streamlines the installation of critical components like the weather-resistant barrier and air barrier. Plus with zip system R-sheathing, you get continuous installation for wall assemblies all in one efficient package. These products aren't just about ease of installation, however. They help builders meet vital performance goals. Think lower blower door scores and even Energy Star certification. Achieving higher efficiency has never been easier. What are one of the standout features of zip system, you might ask? The tape seams create a tight barrier against air leakage, resulting in a more energy efficient building enclosure. I gotta tell you, this is a game changer for the comfort of the homes that we build, and I absolutely love this feature about Zip, is that it's not just waterproof, but it's naturally very airtight as well. Zip system has fundamentally changed the way homes are being built today, and the best part, these innovative products are available nationwide. Just ask your local lumberyard. And here's some exciting news. There's a rebate offer for Zip system products. Just use the link in the description to learn more. Let's build better together. Check out those rebates and make the smart choice with Zip System today. All right, Steve, where do we start on this topic?
Well, you know, I've heard you say it. I've heard Joe say it. Don't do stupid things. Right? And
we do a lot of dumb things in this industry.
When it comes to inside versus outside, you know, so let me set the stage for stupid things. All right. So we're in a part of the world where Peter Yost and I, earlier that day, we measured temperatures in the attic of about 165 degrees.
Ooh, that's hot.
It's very hot.
That's like Texas.
It's not far from here. Yeah. And after that, we went and saw a house. And a gentleman said, hey, this is my dream house. I'm the builder. And we got a tour of the house. And then we started walking around and I saw this. The ductwork is outside of the house.
So we're looking at the front porch and we're kind of looking up at the ceiling on the front porch? Is that where we are?
Yes, that's exactly it.
Okay.
But understand, that ductwork wants to get a room to 70. Look at this disparity.
Whew. Almost 100-degree delta.
Almost 100-degree delta.
Oh my
So when you talk about doing dumb things, right? And I have a little bit of humor. I told the builder, I said, you would have been better off running that outside across the top of the roof and then coming in. It would have been more efficient by probably 30% and a lot cooler. Yeah, he didn't like my joke. So, but anyways, you can see it's not hard. It's not us up here talking green. It's not up here talking sustainability. It's up here talking common sense.
Yeah. You know, our ductwork, we want to try and get it as tight as we can. But ultimately, there's some amount of leakage, even with a really well-built house. Even with my terrific crew, which I love, we typically are seeing 3, 4, 5% air leakage on a duct system. So by running that outside, it means we've got our air-conditioned air that we paid money to get that air to, let's say, 55 or 60 degrees to run in those ducts. We're running it through a really dumb space, but we're also running it in a space that's going to leak to the outside, which means we're going to put a negative pressure on the house, and there's just all kinds of reasons why it's dumb. It doesn't make a lot of sense. The other thing to think about too is that ductwork up in that space is maybe R7, R8, R9, R10 maybe, whereas the rest of our house, our ceiling might be R40. So there's just so many reasons why putting ductwork outside is not smart, and ultimately it does come back to our air barrier or our air control layer.
Right, in this house here, you know, we have all of these big holes here, and so this air is going up. Well, if we're thinking they're allowed to do this, there's probably 40 can lights in that ceiling that are penetrations.
Yep.
That the whole thing is kind of, you know, dream house, and then you're doing this. we really got to start grasping these simple concepts.
That's for sure.
So, starting at the bottom, our good friends at Stego. This is their vapor barrier, but it also is an air barrier when you tape it. And then we'll put the concrete on top of it, and then we'll make that connection. Now, here you can see we actually made the connection to the closed cell foam there, and here, and then the closed cell foam is making the connection to the concrete, but we're actually going to come over the top of this with another 2-inch flash.
So in other words, this
cell.
Stego, this yellow-green membrane is running up the walls. It was probably taped to the walls.
No, it's taped on the top. We taped it on the top here because the concrete guy was complaining, I got nothing to snap a line to.
Got it.
If I turn this up. A lot of people want to turn it up 18 inches. I'm saying this is a little atypical of what you see. We did check with Stego, and they were perfectly fine with the detail.
Gotcha. So in other words, we're still making our air barrier connection at the ground level, and we're not even necessarily getting into radon today. There's a whole nother probably module we need to talk about as we get into further building science. I suspect that pipe sticking up on the left has something to do with radon mitigation.
This one is a drain. The radon pipe is actually that one
there you go. Yeah.
But you're right. I mean, you think of radon as bad stuff. I don't want bad stuff in my house. I got to put a barrier between me and the radon.
Yep.
So this one here, we're looking up at a ceiling. This is interior ceiling here. This is outside with a roof on the outside. But notice we brought our primary air barrier all the way down, and we've connected it to that LVL, and then we'll connect on the inside here with our air barrier. So it's just showing that continuity of, rather than stopping it up at the trusses and having this open to the outside, it brings that down.
Gotcha.
And then this is just another one. This is a porch roof, but the important thing to understand here is our primary air barrier goes up behind all of the ledgers and all of the framing there.
Yeah, so in other words, we didn't do this ledger board and then sheath to it.
Right.
We ran our sheathing all the way up and then did that, kind of like what you saw in Monopoly framing on my house. We did all the air barrier framing with our air barrier, which in my case was the zip system sheathing, and then we bolted everything through that.
Yep. And notice even the little bump out, it's got a cap, so we're very conscious of, this is our good friend at Shoreline Builders, Jim. And for those of you watching, this is not an exterior duct. That is one of the bath fan exhausts that's coming through the system. So
gotcha.
I don't want to.
That's good. Good clarification.
So a lot of people say, can I have a wood stove in my house? Can I put a fireplace in? So this is a Reyes system. The beauty of the Reyes system is it's a closed system. So even though it's inside the house, the combustion chamber there is outside of the house.
So in other words, it's sealed combustion, and I'm betting that this pipe, which is probably behind that wall,
is exactly right.
bringing the combustion air in, and then that pipe, which is at the ceiling,
that's up here,
is taking the exhaust out. So air comes in, it burns it in a sealed chamber. When you probably close that door, I bet there's a gasket
it's a
that
nice
closes
gasket,
into.
and it seals up beautifully.
And then they send those exhaust gases out. So now we still have a fireplace, but we've got good air tightness. Whereas most fireplaces are a big hole in the house. The chimneys can be incredibly leaky, and it's very hard to bring air in to burn in there without having an air leakage all the time.
Yeah, and we've done a number of these systems, and they work out very, very well. The engineering is superb, and you can have it. A lot of people say, oh, but I really want this, but I know I can't have it. No, you can. There are systems.
Very cool.
And then this is just another one. This is more of the general air barrier continuity through here. Again, a porch roof, you can see the top of the door here, and all of the framing, all of the truss roof, it's on the outside. How many times you go up, you see this goes up and stops here.
Yep.
And then I can look into the wall there. It's a no-no.
Yeah, and you'll see some builders, including myself, that over the years have relied on spray foam, let's say, to make that connection. Right. Which can work, but it doesn't work nearly as well as you think.
No,
so I've stopped relying on that.
Yeah, and if you remember in 101, we actually talked about it, right? In this case here, you build the green box and then add everything to it. This is a Sega membrane, and this gets back to the continuity of how do we do that, right? We want to be able to separate this lower portion or the conditioned space from the attic. And so in this one, we're basically prepping for that membrane where you can see it's draped up and over. And then we set our trusses. We flip this up, staple it off to the trusses, and then we can connect from that flap across to that flap.
So a piece of tape on the right, piece of tape on the left, another continuous membrane, and now we've got an air barrier at the ceiling line.
Exactly.
Really smart.
Yeah, and a lot of people, you know, oh my God, all this work. But, you know, the builders that I've worked with that I would consider very, very successful, they've figured this stuff out. They understand the sequencing. They have really good planning. And it just really isn't the hardship that some people look at this and say, oh my God, you're asking me to do all this. Well, you're probably not planning out the project anyway.
Yep.
Right? So in this photo here, you can see this is very similar to the last one. We brought that Sega membrane in, but this is Jake giving us a manifold for all of the wires that we're going to run through that membrane.
So what's behind there? Walk me through what we're seeing.
So we have vented attic.
Okay.
And then we come down and we have this raceway here that's about half the size. You can see enough to fold those wires. And then all of these wires are just going to run in here and go to the panel. But that allows us to get up into the attic and go over to the boxes, and then we can just treat those boxes individually.
And how is the air sealed behind there, Steve? Is there a racetrack, and then later he's going to come in and seal each individual hole?
Yeah, he'll just come in and they'll just spray foam or air seal it, or if the insulator's there, they can just splash the back of that with an inch of closed cell or something.
Got it. So the back side of that could get some closed cell foam, and that would seal all those wire penetrations all in that one spot.
The thing I like about this is the durability of that. Rather than just cutting a couple holes for the lighting, or drilling a whole bunch of holes in the wall here, having it in that one place that
That's really smart.
And then, like all of our series here, we like to get into the little details. This is the little bracket that holds the window in. So you're looking at the window here, and we have that opening, but that bracket creates little holes here. They might not seem like much, but when you're talking 6 brackets, 7 brackets times 35 windows, it's a significant
So this is a
hole.
European window that instead of having a nail a flange on the outside, it's using brackets on the inside that screw into the jamb.
Right.
And what you're seeing is that just an extra piece of tape basically makes that continuous air barrier all the way around that
Just
window.
go around and you place a patch on it.
That's really smart. I've said that a lot. That's really smart. It's because these are
We're
good
doing
photos.
smart things.
Yeah.
So you've been to this house. So this is an attic hatch. This is a attic. We're looking up at it. It has about 20 inches of blown cellulose up there.
Holy cow.
And what we're looking at here is this is the detail at the ceiling. So it's just a real simple reveal. We don't care if air is getting in around there, because 18 inches upwards of that, we have a fully sealed frame that is mechanically fastened. So we have that plywood on the top, and it's being pulled down against a gasket that's on the top of those 1x4s.
And there's probably insulation on top of it.
And there we have some polyiso that is attached to the top of that plywood.
Very smart.
So, and of course, another detail. If you're going to put holes in the ceiling, we got to maintain continuity. If this is our air barrier here, and we put a hole there, we have to make that connection. So going around and sealing that stuff up. Now, we get a little crazy here, and I know people are going to say, oh my God, Steve, all these details. But yeah, in some of the passive houses that we do, we're striving to get under 0.6. But if you can get under 1.5 or 2.0, I'm real happy with that house.
Those are great numbers.
Right?
Yep.
These are just some simple things that you can go and help that number out.
That's right. Now, Steve, let's talk Texas a little bit. You showed a porch ceiling, and you were absolutely shocked to see ducts outside of the air-conditioned envelope. But, when I moved here to Texas, this is the attic in the house that I bought, the 1970s house. And I went up in the attic for the first time. Actually, that's not true. This is my neighbor's house, but same construction as mine. There's a light tube coming down, one of those tunnels for light. There's a gray duct through there. There's kind of blown in and bats willy-nilly through that attic. It's a ventilated attic space, but it's absolutely common to see that in that vintage of house. 1970s. That's 50 years ago, right? You would think that after 50 years, we would up our game. But if you'll forward to the next slide, here's a brand new construction from a builder in a neighborhood where I was building in. 50 years later, this is, I don't know, 5-10 years ago, so not 1970s anymore, close to 2020, same exact system. Instead of gray ducts, now we've got maybe some foil-faced duct. But what's happening here is all these ducts are going to run through the attic, which is a ventilated and hot attic, just like you talked about at the beginning. It's 160 degrees on that attic in a typical July day. You're going to find sweaty ducts up there. You're going to find a fair amount of kind of black stuff, moldy looking stuff growing in various places because of condensation issues. You're going to find leaky ducts. It's just crazy that even 50 years later, we're still building with that style down here in Texas.
Yeah, well, I want to take a second and correct my math because I talked about it being 165 degrees in the attic and 70 degrees in the room. Remember, that's the room temperature.
Downstairs.
Downstairs.
Right.
What temperature does the air actually moving through the duct have to be at to get down to that?
Yeah, I mean,
in that environment.
It's usually 55-ish, let's say, out of the air conditioning coil, which means that the first couple minutes that AC runs, you're actually heating the house.
Yeah.
Because if the AC's been off for a few minutes, these ducts get really hot, so it's 120 up there, let's say. And if you put your hand up by that ductwork, when it first turns on the air conditioner, it's hot air that gets blown in first.
So let's blast the room, and then we'll decide to treat it. Yeah,
exactly.
Such a great idea we have.
It's really bad. But again, this all goes back to that air barrier concept. And there's some things we can do. This happens to be an image from one of my videos that I talked about, Insulation 2.0, where we're air sealing. We're doing as good a job as we can to try and air seal between the house, the existing house, and this ventilated attic. But ultimately, this is a new construction-related series. We're teaching people the best way to do it. Let's talk about the best way to do it, especially in Texas where we don't have basements. We're slab on grade typically here, and there's a number of reasons for that. We have a lot of rock down here in the south. We also really don't have a frost line like you do in the north, so we're not worried about freeze-thaw issues. So with slab on grade, we don't have that basement mechanical room. So now we got to figure out where we're going to put our HVAC system. And you'll see a lot of my videos, Steve, a lot of the stuff I talk about for building here in Texas is we'll use some method to bring that insulation from the ceiling line to the roof line.
Yep.
It costs a little bit more than some of the methods that I've seen you use, but it allows me the space that I've already got to run my HVAC system. So now that ductwork that you see in there.
Yeah, that's 70, and maybe worst case, it's 85 or something up there.
Yeah, I mean, I've hardly seen it more than about 5 degrees hotter than the set point in the attic. It just doesn't get that hot up there.
A more tolerating
So that happens to be closed cell foam. That could be one way to do it. But if you'll forward to the next slide, you'll see a couple houses. One of them is particularly near and dear to my heart. That happens to be my house on the right. And remember, we talked about my monopoly framing earlier, which means I've got this really tight attic space. So now I can run my insulation up at my roof deck, and this time I'm able to use kind of more standard insulation. That's rock wool. And that happens to be my buddy Trey's house, which he built probably 10 years ago now. And you're seeing both of our equipment now is running through the air-conditioned space of the house. The only difference between this and another room in the house is this room doesn't have drywall. Other than that, it's within the air barrier of the house. All that air conditioning is running within the air barrier. So if I get a little bit of leakage in the duct, I don't depressurize my house. I don't have any, to your point, ducts going to the outside. It just makes a giant difference in the house. And as we close up this particular portion on air barrier, Steve, I want to quote you from one of your seminars a couple years ago. I love this quote of yours. It's not that high-performance houses cost too much. It's that our idea of a fairly priced new home is based on a history of building houses to meet embarrassingly low performance benchmarks. Yeah. I think that's ultimately what we're talking about here is, look, we can build better if we know better. And if we know better, we should build better.
Yeah. And I think, you know, homeowners, some of them just don't know what questions to ask. So hopefully these videos are helping out in, hey, the homeowner saying, if we're going to put my ductwork up there, shouldn't we have the insulation on the other side of the ductwork, right? They don't have to be a mechanical engineer to pose some common sense questions.
That's right.
And if you're a builder out there, I'm not suggesting that you go from what you're doing today to building passive houses tomorrow. All of these concepts, they're just stepping stones. The next house you build, get that air tightness a little better. The next house you build, move the insulation up. The next house you build, make your ductwork a little bit tighter.
That's right.
You know, and in 5-10 years, you'll be building a superb house.
Absolutely. What's next, Steve?
Escalation. That's
Ooh.
when air leakage becomes a problem.
Ooh, this is exciting. Guys, stay tuned. Build Science 201, air control, escalation. See you next time on The Build Show.
Sponsored by Anderson Windows and Doors, Huber Engineered Woods, and Proseco. This is Build Science 201.